here we go. I am Mr. Bishop, the guy writing the fall leaves right there. This is Chapter 2, Day 7. We're looking at real-world applications of many solutions in our systems of linear equations. So since we already know what it looks like to take a system of equations into an augmented matrix, and then from there put it into RREF form and identify whether it has one, none, or many solutions, as in the last video, we're going to go right to a couple problems from today's worksheet. Starting with the bottom question on the first page, number 44 about nutrition planning, it says the nutritional content of 3 foods is given by the accompanying table. And there it is, there's your table. Show that there are several combinations of the 3 foods that meet the requirement of 72 units of B12, 68 calories, and 64 units of iron. And for our purposes, we're going to give 2 possible combinations that work here. So apparently there's 3 types of food available to eat in this problem, right? Food A, it's got some B12, calories, and iron. Food B has a lot of each one. And then food C. So let's go ahead and fill in the requirements here. We know it's 72 units for B12, 68 units for the calories, and 64 units for the iron. And then from there, we are going to take our table. We could write it as a system of linear equations, right, with x's, y's, and z's. But we know we're just going to have to put it into an augmented matrix anyway before we do the RREF command. So let's go ahead and put this into an augmented matrix. There we go. Same organization. Now it's just in a matrix. And then we'll use our calculator to run the RREF command. That's reduced row echelon form. We should get something like this. So notice right away we're not going to have a clear-cut solution, right? Usually when we do RREF, we like to see 1s and 0s everywhere in here. We've got some other numbers going on. We've got a row full of 0s at the bottom. Let's put this into XYZ form. So that first row, if we put that into our XYZ equation, that's going to be 1x minus 25z equals negative 46. The second row there is going to be 1y plus 9z equals 21. And the third row there, it's great. It's a little bit extraneous here, right? 0 equals 0, that's nice. Doesn't tell us a whole lot. So for now, I'm just going to disregard that since we're going to have to use these 2 equations to substitute values. So technically, there's an infinite number of solutions possible based on these 2 equations. X, Y, and Z can all change depending on what we plug in for a given value. So the table down here is what we'll use to plug in values and see what the resulting answers are. And I'm going to plug in for Z. I think that would probably make our lives easiest because Z is in both equations. And remember, we can start by plugging in whatever value we'd like. So for example, I like to plug in 0 a lot of times for Z. The only issue with that is that's simply not realistic here, right? If you plug in 0 for this Z right here, you're going to get x minus 0 equals negative 46. So you're going to come over here and tell me you need to eat negative 46 units of food A, right? So that's simply not plausible. So 0 is not going to work here. I'm going to go ahead and erase this. Okay, what about if you plugged in 1 for Z? Would that work? If I plug in 1 for Z right here, x minus 25 equals negative 46. So if I add 25 to both sides, I'm still going to get a negative answer for x. So putting in 1 won't work either. So I'm going to take that out. So 0 won't work for z, 1 won't work, but we're getting warmer. What about if I plug in 2 for z? If I plug in 2 for z, then I'll get x minus 50 equals negative 46. Right? So if I add 50 to both sides, that actually would work out. I'd get positive 4 for x here. And if I had z equals 2 in the second equation, that'd be y plus 18 equals 21. What number plus 18 gives you 21? Well, 3. All right, so we've got a winner here. Plug in 2 for z, and the other two answers work. What's one other combination? We only need to get 2 for this question. What's one other answer that would work here? All right, 2 worked for z. What about if I plugged in 3 for z? Right? Would that be okay? Let me erase some of these little arrows and so forth up here. Plug in a 3 for z. Would that fly? There we go. Well, it would work okay up top, right? If you plugged in a 3 for that z, you'd get x minus 75. You add 75 to both sides, you'd get some positive answer for x. But if you plugged in a 3 for this z, you'd get x, or you'd get y plus 27 equals 21. So when you subtract 27 from both sides, you'd get a negative answer for y, which is no good. Right? We can't have a negative answer for units of food B. So 3 is not going to work here for z. 0 didn't work, 1 didn't work, and now 3 is too big. So can we think of a number that's really close to 2? How about, say, 1.9, right? Think of a number that's really close to 2, because 2 seemed to work. 2 was like the Goldilocks zone, right? 1 didn't work and 3 didn't work, but 2 was okay. So if I plug in 1.9 for z, right, then if I plug it on the top equation, that gives me x is equal to 1.5. And you can check it with your calculator if you don't believe me, or if you can't do it in your head. And if you plug it into the bottom equation there, that gives us positive 3.9. So there's our other winner. We plug in 1.9 for z, and that is a success. I'm going to go ahead and highlight this one too. There we go. So there's our 2 combinations. That one was a little bit more difficult, right, because we couldn't get negative answers for the units of food. What are some other numbers that would probably work for z? I don't know. Maybe 1.8 would work. Maybe 2.1 units would work for z, right? Numbers that are around 2. All right, let's look at one more question in this video, the very last question on the worksheet about flowers or buying flowers. It says, Amanda is decorating her new home and wants to buy some house plants. She's interested in 3 types of plants. We'll call them plant A, plant B, and plant C, costing $7, $10, and $13. So that means A is the cheapest one and C is the most expensive. If she has budgeted exactly $150 for the plants and wants to buy exactly 15 of them, what are her purchase options? And let's give her 3 different outcomes. So for starters, we need a couple equations before we can move forward with solving this thing, right? And my hint is always to look for the totals. In this case, we could start with, well, the total number of plants that she's going to buy. For example, all of plant A plus all of plant B plus all of plant C should add up to, let's see, 15 plants, right? It says she's going to buy exactly 15 plants. So the total number of plants, there's one equation. And then the other equation would be for the total amount of money she's going to spend. It says she's going to spend exactly $150. So how much does it cost for each one of those plants? $7 for plant A, plus $10 for every B plant, plus $13 for every C plant. So no matter how many she buys of each, it has to add up to $150. All right, so we've got our two equations based on the total number of plants and the total amount of money spent. We could write these with X, Y, and Z, but we know that X represents the number of plant A, Y represents the number of plant B, and so on. So let's go ahead and put this into our augmented matrix before we do reduced row echelon form. There we go. There's our augmented matrix. That's a 2x4. We put that in our calculator and run the RREF command to get this in reduced row echelon form. And this is what we get. Okay, now to move forward with solving this thing and giving Amanda three different options. Let's put this into XYZ form. The first row there is going to be X minus Z equals 0. And the second row there is going to be Y plus 2Z equals 15. All right, and then looking at our table, again, we know plant A, plant B, and plant C are represented by X, Y, and Z. We can plug in to any of those variables. But since Z is in both of the equations, right, I want to make life easy on us. Let's plug in values for Z. And you know the easiest value we can plug in to start off with? What if she just doesn't buy any of plant C, right? So I'm going to plug a 0 in for Z here. What if she doesn't buy any of that plant? Well, that would give us 15 for plant Y, right? Because Y plus 0 equals 15, right? So that would mean 15 of plant Y, which she's only buying 15 plants total. So if you plug in a 0 for Z, what number minus 0 gives you 0, right? That means X is 0 as well. So it looks like the number of plants from plant C and plant A have to be the same, right? Because X minus Z equals 0. Those numbers are always going to match. So if she buys 0 from plant C, that means all 15 plants come from plant B, and she doesn't get any plants from plant A either. Okay, what's another easy number we could plug in for Z here? Well, we already did 0. How about 1? If you plug a 1 in to the bottom equation for Z, Y plus 2 equals 15. So what number plus 2 gives you 15? I guess that's 13. So she's going to buy 13 of plant B in this case. And then if we plug in a 1 in the top equation for Z, X minus 1 equals 0. Add 1 to both sides and you get 1 for X. So that's another combination that she could use. She could buy 13 of plant B, and that leaves her with 1 each from the other 2 plants. Okay, one more number to plug in for Z. We've done 0, we've done 1. How about 2? If you plug a 2 in for Z, in the bottom equation, we get Y plus 4 equals 15. You subtract 4 from both sides, we get 11. So that's 11 for plant B here. And then if you put 2 in the top equation, let's see, X minus 2 equals 0. Add 2 to both sides. That's 2 for X. So there you go. That is our third and final outcome for Amanda here, buying houseplants. All right, so we've looked at applications of when we might get many solutions as a result from our augmented matrix. Again, we're plugging in values to see which ones would work and give us our 2 to 3 different solutions. That's all for this video. Thanks for watching.